8.8 Covalent bond strength. Most simply, the strength of a bond is measured by determining how much energy is required to break the bond. This is the bond enthalpy. The bond enthalpy for a chlorine to chlorine bond is measured to be 242 kilojoules per mole. We use the letter D followed by the bond in question to represent bond enthalpies. Average bond enthalpies. This table lists the average bond enthalpies for many different types of bonds. Average bond enthalpies are positive because bond breaking is an endothermic process. The bond enthalpy is always a positive quantity. Energy is always required to break chemical bonds. Conversely, energy is always released when a bond forms between two gaseous atoms or molecular fragments. The greater the bond enthalpy, the stronger the bond. Also, a molecule with strong chemical bonds generally has less tendency to undergo chemical change than does one with weak bonds. You should note that these are average bond enthalpies, not absolute bond enthalpies. For instance, the carbon-hydrogen bonds in methane will be a bit different than the carbon-hydrogen bonds in another compound like chloroform. Another way to estimate the enthalpy change for reaction is to compare the bond enthalpies of bonds broken to the bond enthalpies of the new bonds formed. In other words, the enthalpy of the reaction is equal to the sum of the bond enthalpies of bonds broken minus the sum of the bond enthalpies of bonds formed. In this example, one carbon-hydrogen bond and one chlorine-chlorine bond are broken, and one carbon-chlorine and one hydrogen-chlorine bond are formed. So we can see that here we have our reactants, we have our methane and our chlorine gas, and here we have our products. We have our, we can see that in this structure, this hydrogen was taken away. So it's a carbon to hydrogen bond that's broken. And that this bond here between the two chlorines was broken. So again, we see that a carbon to hydrogen bond was broken here, and one chlorine-chlorine bond was broken here. And then on this side, on the product side, we see that a carbon to chlorine bond was formed and a hydrogen to chlorine bond was formed. So we can write out our math. Again, we have the sum of the bonds broken minus the sum of the bonds formed, and all of those values are tabulated so we can get the enthalpy of the reaction. Bond enthalpy and bond length. We can also measure an average bond length for different bond types. We know that a triple bond is shorter than a single bond between carbon and hydrogen, for instance. As the number of bonds between two atoms increases, the bond length decreases. Sample exercise 8.12, using average bond enthalpies. Using the tabulated values, and estimate the enthalpy for the following reaction, where we explicitly show the bonds involved in the reactants and the products. We're asked to estimate the enthalpy change for a chemical process by using average bond enthalpies for the bonds that are broken in the reactants and formed in the products. Among the reactants, we must break 6 carbon-hydrogen bonds and a carbon-to-carbon bond. We must also break 7 half oxygen bonds. Among the products, we form our carbon-to-oxygen double bond, 2 in each of the two in the carbon dioxide molecule, and then 6 OH bonds, 2 in each of the water molecules. Again, our math values are all tabulated. We have the sum of the bonds broken minus the sum of the bonds formed. And we can also check this estimate based on calculated values, and there's a good agreement there. So for practice, you're going to estimate the enthalpy for this reaction. You're going to have to break 1, 2, 3, 4 nitrogen to hydrogen bonds and a nitrogen to nitrogen bond. So those would be the bonds broken. We're going to form a triple bond, and we're going to form 2 hydrogen-hydrogen bonds.